This lesson on right triangle trigonometry combines both lessons 7.5 and 7.6. Trigonometric ratios. There's three main trigonometric ratios, which basically describe the relationships of the various sides of any right triangle. There's actually 6 of them, but the other 3 are the reciprocals of the 3 main ones that we'll talk about. And we'll use these ratios to find the lengths of missing sides of various right triangles. The sine ratio. Given a right triangle is labeled below. Notice that I'm labeling the sides in relation to a single angle. So side AC is considered the leg adjacent to angle A, and side BC is considered the leg opposite of angle A. And then the hypotenuse, of course, is the leg that is opposite the right triangle. Sine of A is considered to be the length of the leg opposite of A divided by the length of the hypotenuse, or BC compared to AB. We can find the sine of A when we're given the length of the sides. Remember that it is the opposite leg over the hypotenuse, so angle A is up the top of this triangle, so the opposite leg has a length of 8 and the hypotenuse has a length of 10. Therefore, it is 8 over 10, 4/5, or 0.8. The cosine ratio looks at a different relationship. It looks at the relationship between the length of the adjacent leg and the hypotenuse. So in this case, I have AC over AB as the ratio that represents the cosine of A. So to find the cosine of A, I see that A is at the top. For cosine, I want the adjacent leg, which is AC, or a measure of 6, over the hypotenuse, which is 10. So that is 3/5, or 0.6. The last one will relate the opposite leg with the adjacent leg. We've already looked at opposite and hypotenuse. That was sine. Adjacent and hypotenuse was cosine. The tangent looks at the relationship between the length of the leg opposite and the length of the adjacent leg. In order to find tangent of A, I need the length of the opposite over the length of adjacent. Since A is at the top, the opposite is 8, the adjacent is 6, so the tangent of A is 8 over 6, which is 4/3, or 1.33. So how do we remember these? Well, we're going to use a mnemonic device that sort of lays out how we can think about this. We'll rely on my favorite Indian chief, Chief Sokotoa. Now, I know this seems kind of silly, but it will help you remember the relationships between the sides. Sokotoa. So, sine equals opposite over hypotenuse. So we're using the first letter of sine, opposite, and hypotenuse. The ca part is CAH. Cosine is equal to adjacent over hypotenuse. And the toa is tangent is equal to the opposite over adjacent. Like I say, this may seem silly, but it can help you figure out which one of these you need to use and how to set up your equations. Let's look at these. Remember, I'm going to use my old Indian chief, Sokotoa, to help me remember. I want to find the sine, cosine, and tangent of angle R. So I'm looking in relation to angle R. For sine, I know I need opposite over hypotenuse, the so part. The opposite is ST, and the hypotenuse is SR, and so I plug in those values, 18 over 82, and I can then punch it into the calculator and round. The cosine is adjacent over hypotenuse. The adjacent is TR. The hypotenuse, again, is SR, so that's 80 over 82, or about 0.9756. Then last, the tangent, as we said, is the opposite over the adjacent, TOA. Tangent is opposite over adjacent. And so the opposite is ST, and the adjacent is RT, so that is 18 over 80, which reduces to 0.2250. So, how are we going to use these to find a leg length? Well, I'm going to look at it. I'm going to keep in mind this SOHCAHTOA so that I can decide which of these three I'm going to use. I look at the angle that I'm dealing with, angle 32, this 32 degrees. That's this angle down here. In relation to this angle, I know the opposite, and I'm looking for the adjacent. Opposite adjacent fits into the tangent is the opposite over the adjacent. So in order to work this, I'm going to use the tangent, and the tangent of 32 degrees will be equal to the opposite over the adjacent. That would be the tangent of 32 degrees is 11 over x. From here out, it is simply doing your algebra. I will multiply both sides by x. That gives me x times the tangent of 32 degrees is 11. I will divide by tangent of 32 degrees in order to get x by itself. And from there, I can simply punch it into the calculator. Now make sure that your mode is set for degrees because we're dealing with 32 degrees. And if you look at the mode on the calculator, you'll see that you can set it as radians or degrees. We need to have it as degrees. Then when we punch it into the calculator, we get 17.6, or approximately 17.6. Let's look at another one. You want to string a cable and make a dog run from two corners of the building as shown in the diagram. Write and solve a portion using the trig ratio to approximate the length of the cable you'll need. Well, I notice I have a 35-degree angle right here, and the side opposite of that is 11, and the cable that I'm looking for is the hypotenuse because my right angle is in the corner of this building here. Therefore, I need something, if I think of my SOHCAHTOA, then I'm dealing with opposite and hypotenuse, so the sine is the opposite over the hypotenuse. So sine of 35 degrees would be equal to 11 over x, and once again, now it's just algebra. Multiply by x, divide by sine of 35 degrees, make sure your calculator's in the right mode, and punch it in. So x is approximately equal to 19.2 feet, so we need a little bit more than 19 feet of cable. Here's another problem. Lamp post. What will we use for this one? I see that I have a 70-degree angle here. The side that I'm looking for is opposite. The side that I know is adjacent. Opposite and adjacent deals with tangent. Tangent of 70 degrees is equal to h over 40. To get h by itself, I simply have to multiply by 40, and that will give me approximately 109.9, or about 110 inches. Let's use a special right triangle to find some special ratios. Special right triangle where to find the three trig ratios of a 60-degree angle. Now remember, if it's 60 degrees and it's a right triangle, that's a 30, 60, 90 triangle. Now we can simplify this a little bit by choosing to make the shortest length 1. We'll talk about why it doesn't really matter what we make the shortest length in a little bit, but right now let's just make it 1 to make the calculations a little easier. So I have a 30, 60, 90 triangle, and I make the short side 1. We know that our long side is simply the short side times the square root of 3, and 1 times the square root of 3 is simply the square root of 3. We can also get our hypotenuse because it's simply twice the short leg, so 1 times 2 is 2. So now I have my 3 legs, and I can write my trigonometric ratios for the 60-degree angle. Remember, sine is opposite over hypotenuse. The opposite of the 60-degree angle is the square root of 3, and the hypotenuse is 2. So the sine of 60 degrees is the square root of 3 over 2. My cosine is the adjacent over the hypotenuse. So that will be 1 over 2, or 1/2. The tangent is the opposite over the adjacent, so the square root of 3 over 1. Now this will be true for any 30, 60, 90 right triangle, because all 30, 60, 90 right triangles are similar to one another, so those ratios will always come out to be the same. Find the value of x and then round to the nearest tenth. Okay, let's decide which one we're going to use here. So my 61 degrees, I have opposite and adjacent, and so if I do the SOHCAHTOA, I can see that opposite and adjacent is tangent, so I'm going to use tangent. I get an answer of 12.2 when I set up the equation of the tangent of 61 degrees is equal to 22 over x. Remember, I would have to multiply by x and then divide by the tangent. Punch that in the calculator and you should get approximately 12.2. In this problem, once again, I have 56. I notice it is the opposite and the adjacent. I'm not dealing with the hypotenuse here. So once again, that's tangent, so it will work the same way. Simply plug in and do the proper algebra. What if in example 7, suppose the side length of the shorter leg is 5 instead of 1. If we'd used 5 instead of 1, show that the tangent of 60 degrees is still square root of 3. Well, let's look at that. Let's set this up where I've got a 30 degree, a 60 degree, and a 90 degree angle, but this time the short side is 5. Well, my tangent of 30 is opposite over adjacent, so the adjacent is the long side, so that's 5 square roots of 3. So if the shorter leg is 5, the longer leg is 5 square roots of 3, so tangent is 5 square roots of 3 over 5, and we can see that still simplifies to 3. That's what I was saying earlier. All 30, 60, 90 triangles, those ratios will come out to be the same. You're skiing on a mountain with an altitude of 1,200 meters, so it's 1,200 meters high, and the angle of depression is 21. And notice an angle of depression is the angle measured from looking straight out and then looking down. The angle coming down off of the parallel to the ground will give me my angle of depression. I have the opposite. I'm looking for the hypotenuse, so I will use sine, plug in, and do my math, and I come out that it is about 33.48. So you ski about 3,348 meters. What if? Suppose the angle of depression is 28, about how far will you ski? So you're going to use that same equation, but this time you're going to punch in for 28 degrees. Sine of 28 degrees, and it comes out to be about 2556. A skateboard ramp. You want to build a skateboard ramp with a length of 14 feet, so the ramp itself is going to be 14 feet long. Notice that's giving us the hypotenuse, and the angle of elevation will be 26 degrees, and so I want to find the height of the ramp and the length. Let's start with the height. Since this is 26 degrees, the height is opposite. We know the hypotenuse, so we're going to find sine first. Sine of 26 degrees. When I punch in and solve, I get that it's about 6.1. For the length of the base, I'll use cosine because I'm looking for the adjacent and I know the hypotenuse. So I'll plug in and work that and find out that the length has to be about 12.6 feet. What if in example 9 the angle of elevation is 35 degrees? What's the new height and base of the ramp? You do work those same problems, except this time you use 35 degrees. You'll find out about 8 feet tall and about 11.5 feet long. It says to use a special right triangle to find the three trig ratios of 30 degrees. Let's draw our triangle. There's 30 degrees. Then this is the right angle. That makes this one 60. Now, what are we going to do? Well, we're going to throw in those same numbers. Let's use 1 for our short side. That makes the hypotenuse 2, makes the long side square root of 3. So my sine of 30 is opposite over hypotenuse, so that's 1/2. Cosine of 30 is the adjacent over the hypotenuse, so square root of 3 over 2. And then the tangent is